Good morning, good afternoon, good evening, and good night. My name is Jeremy Antonio Gunawan. I am from the class Fluid Mechanics 3, and today I'm going to tell you about the third assignment that Mr. Dai gave us, which was an experiment, a simple experiment that explains the basics of fluid mechanics. So this is my experiment. Um, the experiment I did was about the leaking of bottled water. We can commonly find this usually on the questions of the national exam, usually on high school, which usually is a tank that's leaking, and we have to find either the distance or the speed or the height of the hole. That's usually what happens. So this is the experiment. So this experiment aims at finding the relationship between the height of the hole in the bottle, the velocity of the water coming out, and the fluid discharge. So this is the things that are needed: scissors, cutter, ruler, empty bottle, tape, and stopwatch. You can use stopwatch as you can use your phone as a stopwatch. So this is the steps. First of all, make 4 holes in the bottle. Measured the depth of each 8 centimeters, 13, 18, and 23 from the top. And each hole has this 5 centimeter gap to make sure it's accurate. And then cover the holes with a strong tape. I use the silver tape right here, which is pretty strong to make sure the water doesn't leak out when it is being filled. So to make the hole pretty, we can cut it using a scissors for the first time, and then or cutter. I mean, we can cut the hole clean, and then we'll trim it to make a pretty decent hole using scissors to make it just right. So the next thing is, after filling the bottle full and making sure that no water is leaking from the hole, we can open the first hole, which is at the top, using a depth of 8 centimeters from the top. So after opening the hole, we can measure the time using our phone. I use my phone in this situation, but you can use anything. And we'll open the first hole and record the time it takes and measure the time until from the moment you open the tape until the water stops coming out. So that's what you do from the first hole, and then we'll after finishing recording the time, we can tape up the first hole again, and then do the second hole, open the second hole, and fill up the water again, and then open it, and then measure the time again, and then do it with the third hole also and the fourth hole. So after we measure all the time from the 4 holes, and then this is the data I got. So with the 8 centimeter height, the time it takes is 26.84 seconds, and from the 30 centimeters height, it needs 44.37 seconds. 18 centimeters, it needs 77 seconds, and 23 centimeters, it needs 103.06 seconds. So from the data given here, we can calculate some data, and we can get the volume first, which I got from the area of the bottle times the height, which is pi times radius squared times h, the height of the bottle, meters cube. So the next thing I did was count the fluid discharge, which was volume divided by the time, and I count the height based on the water when it's being filled. So we can also get the velocity, which is fluid discharge, divided by the cross-sectional area of the bottle. So after calculating, these are the data from my experiment. We got the height, the time, the volume, the fluid discharge, and the water velocity. So this data, or the results of the experiments, tells us a few things. First, the higher the hole is, or the lesser the depth is, or the shorter the depth is from the top, the less time it takes for the water to leak out, and the less water pressure it receives. So when it's at the most bottom, the fourth hole, it takes the longest time to for the water to leak out, and has the highest water pressure. And the second point is the more time it takes for the water to leak out, the more water volume leaks out. So the higher the time, the higher the volume. And the third point is the height difference is inversely proportional to the velocity of water. So the higher the height is, the lower the velocity is. And the fourth point is the fluid discharge is directly proportional to the velocity of the water. So the higher the velocity, the higher the fluid discharge. Okay, that's it for my experiment. Thank you for listening. Goodbye.